Has it ever crossed your mind how engineers ensure the safety of aircrafts that fly thousands of feet above the ground? It's a question that undoubtedly sparks curiosity. One of the key methods used in this safety assurance is ultrasonic testing. This non-destructive testing technique is crucial in maintaining the safety of aircrafts. Ultrasonic testing plays a critical role in detecting defects or faults in the aircraft structure that are not visible to the naked eye. It's all about sending high-frequency sound waves into materials to identify potential issues. These sound waves can penetrate deep into the structure, echoing back when they encounter any anomalies. This information is then processed and analyzed, providing invaluable insights into the internal health of the aircraft components. So next time you board an aircraft, remember the unsung heroes of ultrasonic testing. Indeed, the safety of every flight begins on the ground with thorough inspections. And ultrasonic testing is a key tool in that process. But what exactly is ultrasonic testing and how does it work? Let's dive right in. Ultrasonic testing, in the simplest of terms, is a non-destructive testing method. Non-destructive means we're not causing any damage to the object we're testing. This is crucial, especially when we are dealing with something as sensitive and vital as an aircraft component. Now, the magic of ultrasonic testing lies in its use of high-frequency sound waves. Think of bats navigating in the dark or dolphins communicating underwater. They use ultrasonic waves, and we're doing something quite similar here. The process starts with producing these high-frequency sound waves and sending them into the material we're testing. But here's the catch. These sound waves are so high-pitched that they're beyond the range of human hearing. We're talking about frequencies typically in the range of 1 to 10 megahertz, a far cry from the 20 to 20,000 hertz range of human hearing. Once these sound waves are sent into the material, they travel through it until they hit a boundary. This could be the other side of the material or a hidden defect within. When this happens, the waves are reflected back and detected by a receiver. By measuring the time it takes for the sound waves to travel and the intensity of the waves reflected, we can not only identify the presence of a defect, but also determine its size and location. In the same way, we can measure the thickness of the material without causing any harm to it. What's more, ultrasonic testing isn't limited to just one type of material. It works on metals, plastics, ceramics, composites, and even on coatings and welds. This versatility makes it an invaluable tool in a wide range of industries, from aerospace and automotive to power generation and oil and gas. In essence, ultrasonic testing is like giving the aircraft a high-tech health checkup. It allows us to see beneath the surface, detect potential problems before they escalate, and ensure that the aircraft is in top-notch condition, ready to take to the skies safely and confidently. Now that we have a basic understanding, how about we dive into the step-by-step process of ultrasonic testing? Ultrasonic testing is a multi-step process that requires careful work and precision. Each stage is crucial to ensure the accuracy of the results. So let's delve into the process and see what each stage entails. The first step is setting up the equipment. This involves preparing the ultrasonic device, which includes the transducer, the couplant, and the calibration blocks. The transducer is the component that sends out the ultrasonic waves and receives the echoes. The couplant is a gel or liquid that helps the ultrasonic waves travel from the transducer to the test material. And calibration blocks are used to set up the equipment accurately. Next comes the calibration. This step is vital as it ensures the device is working correctly and is set to the right parameters for the specific testing scenario. Calibration involves adjusting the device's settings to match the known values of the calibration block. This step is repeated until the device's readings match the known values of the block, ensuring the equipment is correctly calibrated. Now we move on to the actual testing. The transducer is placed on the material to be tested with the help of the couplant. The device then emits ultrasonic waves into the material. These waves travel through the material and reflect back to the transducer when they hit an interface, such as the back wall of the material or a flaw within it. The echoes received by the transducer are then converted into electrical signals, which are displayed on the device's screen. The time it takes for the wave to travel to the interface and back is directly related to the distance of that interface from the transducer. Hence, This information is used to determine the thickness of the material or the depth of a flaw. The final step is interpreting the results. This can be a complex task as the signals need to be analyzed carefully. The position, size, and shape of the echo on the screen can tell us a lot about the material being tested. For instance, a strong echo from the back wall indicates a material without flaws, while echoes appearing before the back wall echo suggest the presence of flaws within the material. As you can see, ultrasonic testing is a meticulous process that requires both technical knowledge and practical skills. It's a procedure that demands precision, attention to detail, and a deep understanding of how ultrasonic waves interact with different materials. But when done correctly, it can provide invaluable information about the material's thickness and the presence of any internal flaws, making it an indispensable tool in industries such as aviation. As you can see, ultrasonic testing is a meticulous process that requires both technical knowledge and practical skills. Let's recap the vital points about ultrasonic testing that we've discussed thus far. Ultrasonic testing, a non-destructive testing method, plays a significant role in the inspection of aircraft components. It's a method that utilizes the power of sound waves, specifically those with frequencies higher than the upper audible limit of human hearing, to detect inconsistencies in materials. This is a crucial procedure in the aviation industry, where the integrity of each component can directly influence the safety of the aircraft and its passengers. The process of ultrasonic testing is both intricate and fascinating. It begins with the generation of ultrasonic waves, typically using a piezoelectric transducer. This device converts electrical energy into mechanical vibrations, producing the ultrasonic waves needed for the inspection. These waves then travel through the material under test and reflect back when they encounter a boundary or a flaw within the material. The reflected waves are picked up by the same transducer, which now acts as a receiver, converting the mechanical waves back into electrical signals. These signals are then amplified and displayed on a screen, providing a visual representation of the internal structure of the material. This allows us to precisely locate and evaluate any potential defects in the material. Ultrasonic testing is particularly beneficial in the aviation industry because it provides a highly accurate and reliable method of inspecting the thickness of materials and detecting internal flaws. This is critical for aircraft components, where even the smallest imperfections can lead to catastrophic failures. Moreover, ultrasonic testing is non-invasive and non-hazardous, meaning it doesn't cause any harm to the material being tested or to the operator. It's a safe, efficient, and effective method that has become an integral part of quality control and maintenance in the aviation industry. In conclusion, the principles of ultrasonic testing may seem complex, but they're based on the simple concept of sound reflection and refraction. The process, while intricate, provides invaluable information about the integrity of materials, helping to ensure the safety and longevity of aircraft components. Ultrasonic testing, though complex, is an indispensable tool in ensuring aircraft safety. To wrap things up, let's talk about how ultrasonic testing is applied in real-world scenarios. Ultrasonic testing is a key player in maintaining the safety and integrity of aircraft. It's not an overstatement to say that this method is one of the unsung heroes in the aviation industry. So, how is it used in practice? Let's delve into that. One of the primary applications of ultrasonic testing in aircraft inspection is to check the thickness of various materials. Be it the fuselage, wings, or engine components, ultrasonic testing can accurately measure the thickness of these structures. This is crucial because any thinning of the material could indicate wear and tear, corrosion, or other forms of damage. But it doesn't stop there. Ultrasonic testing can also detect internal defects that are invisible to the naked eye. For instance, imagine an internal crack forming within the wing of an aircraft. It's not something that can be seen from the outside, and yet it's a potential disaster waiting to happen. Thankfully, the high-frequency sound waves of ultrasonic testing can penetrate the material and bounce back, revealing these hidden defects. Now, you might be wondering, what happens after these defects are detected? That's a great question. The information gathered from the ultrasonic testing is then analyzed by engineers. They use this data to make informed decisions on necessary repairs or replacements, ensuring the aircraft remains safe for operation. Moreover, Ultrasonic testing is not only used for detecting problems, but also for preventive maintenance. Regular inspections help to identify any potential issues before they become significant problems. This proactive approach helps to maintain the longevity of the aircraft and, most importantly, the safety of the passengers and crew on board. So the next time you board an aircraft, remember the vital role of ultrasonic testing in keeping you safe.